Okay, fantastic. I will get going then. Awesome. Well, I'm gonna start with a story. In 1675, Newton sent a letter to Robert Hooke saying, "If I have seen further, it is by standing on the shoulders of giants," which I think this is sort of like the ethos of science. And what is interesting about this is that Newton and Hooke were rivals, and Newton sent that actually as a sarcastic comment to Robert Hooke that was sort of digging at his slight build. And so this is like just sort of like an interesting tidbit, but it's also pointing to sort of the collective and individualistic enterprise of science, and that those two are often not in harmony, that we've seen a lot today. And so that is talking about some of that illustration of those difficulties at play between the personal ambitions and the collective goals, and ultimately sort of, especially in this case, the profound societal impacts of that scientific research. And in these expanding circles of scientific discovery, there are questions to ask on who you work with, how you're going to share that, how that is going to be reused by others, and how there is an alignment of incentives across these different aspects. And so fast forwarding 350 years to from 1666 to 2016, and another discovery about gravity. So 350 years later, this is the LIGO detector, which is listening for gravitational waves with precision lasers. And in 2016, they detected a faint chirp, which was two massive black holes colliding. And so this work won the Nobel Prize in 2017 as the first observation of gravitational waves using sophisticated data collection and software processing to make that new discovery. And if we look at sort of comparing these, like going back to that discovery of gravity in the first place, and then comparing how we communicate that knowledge, the innovation here is like 2 columns. And so that I think is really what I'm taking away. They're good columns. I mean, like it's like very well typeset. And so that I think, especially in what we're thinking about at FORCE, the future of research, communication, and e-scholarship, that's sort of the type of things that I'm taking away from that. And at the keynote this morning, they asked us to dream and engage in questions of what the future of research communication is and how do we affect that change, which will have profound impacts on the next generation of scholarship. And so looking back to the FORCE11 manifesto, there are some recommendations that they had in there that were talking about sort of groundwork to lay about thinking about the future of research communication. And that is incorporating data and software into the workflows of publication as first-class research objects, and rethinking the units and the form of how we publish, and also developing better tools and technologies that better support the entire scholarly life cycle. And so I want to bring in some of my own experiences in tackling some of these changes in a couple different ways. And the first day of my, I have a background in geology and geoscience and environmental science. And the first day of my structural geology class in undergrad, the instructor told us that structural geology was hard because it involved 3D visualization, and some of the students would get it, and some of the students would just struggle to keep up. And what was frustrating was that he was right. There was this bimodal distribution in the grades of the class, and some of the students just couldn't get it. And me, as a software developer, I started developing tools for tackling that visualization by changing the form of how that was communicated. And so a student could then go in and sort of add beds, add folding events, add tilting events, add unconformities and dikes and folds and more faults, and then start to interrogate this and change the unit, or change sort of the order of the geologic history, and understand and engage with different tools. And the feedback after I put this online was quite profound to me. This was the first sort of widely used software project that I had ever done, and people reaching out saying that this was the greatest tool that they had ever seen, and that they would owe most of their success in structural geology to this tool. And so that was sort of a formative experience for me by sort of changing the way we interact with these ideas, and infusing software, we can enhance that learning process and allow students to discover ideas on their own. And so those visualization tools that I built in my undergrad class went on to be used by more than over 1 million geoscience students worldwide. And then I went on to start my PhD, and that was in hydrogeology and geophysics and geology, and sort of creating computational models to incorporate the data between these disciplines. And of course, as in almost all fields of science, there was data that we were working with and sort of collecting that. And then I was quite involved in the software projects of stitching these data sets together and doing optimization routines, coming up with new models. And we were also writing stories about these. And as happens in PhDs, sometimes your colleagues graduate. And when that happened, I started realizing that many of these things that I was relying on for my PhD were not archived correctly, and the data was gone, and the software wasn't really there. And all we were left with was the stories of the papers that were published, and they weren't reproducible. We couldn't actually build upon that work. And so those were some of the ideas that I was thinking about when I was starting my company in 2019, Curvenote, because trying to think about the intersection between software, data, and story, and believing that science deserves better than a PDF, and scientists deserve better tools to communicate their work that incorporates software and data at the heart of the medium. And so we have a lot of tools available through Curvenote, such as writing tools that allow things like citations to be added, and collaboration that sort of deeply references things like figures directly. So you can, in a comment, say the figure that you're referring to, and that actually links up. And tools that allow development environments like Jupyter to deeply connect into the writing environment, so that we're creating links between these two different places. And then we're starting to work more on the publishing side. So having notebooks rendered as articles, and sort of this rich reading experience around all of that. And in 2021, funded in part by the Sloan Foundation, Curvenote open sourced many of these tools to help build and sort of reinforce the MyST Markdown ecosystem. And MyST is a markup language for structured text that can connect data and computation, and includes the specification for the markup language and the underlying structured data. And it has a diverse community that is around it and supports those tools. And so this is not going to be a tutorial about MyST Markdown, but there are lots of tutorials that I've done. And so you can look at mystmd.org to talk about that. But just some highlights from this. These are tools that the sort of ecosystem around them, and JupyterBook and executable books that use MyST Markdown. There are 14,000 textbooks that people have made. These are mostly tutorials and course materials. It's about 13 to 15% of active Python documentation at this stage in terms of being used in the Python ecosystem. And as of about a month ago now, it's officially part of the Jupyter ecosystem, which is a large open source community-run project that, again, incorporates sort of ideas of data, software, and computational narratives. And there are many, many other contributors to the MyST ecosystem. And just to give a very brief idea of this ecosystem, it's this idea of sort of writing once and publishing to many different templates. So we're providing this markup language that you can use command line tools to generate templates. You can generate websites out of this, much like the demos that we were showing at the beginning. And then key to this is the underlying structured data as well. And so coming back to these sort of spheres of influence in science and how they connect, and thinking about a lot about science is bringing data into stories and making sure that we're grounded in reality. And then especially looking at the mediums of how we communicate this. those are all often very, very disconnected. So a caricature of science communication is a 2-column PDF that you're looking at on your phone, and you're like zooming into a table that's sideways, and the data you can't copy out because it includes the page numbers. And that is the way that we sort of experience the connection between data and story in science today. And then software is sort of off to the side. And in other disciplines, and also in the keynote this morning, talking about the value of dashboards and sort of bringing together data and software in different ways. And this really focuses on exploration and asking different ideas of this. But again, the story in this case is left sort of off to the side. And so what happens when we bring software and story together? I think there are very intentional ways to do that, to sort of create connections between people. And we heard maybe this morning from pre-review who was talking about ways to do that. And there's also other companies that know the power of this, of course, in terms of bringing people together, but not in the scientific field. So Facebook and all of the social media platforms are bringing software and data and story together in very, very powerful ways. And there's maybe other ways to look at connection. And some of those in my sort of early educational attempts of understanding how to connect with an idea and bringing software into that idea of telling a story. And as you're bringing data into that as well, you can ask questions of your stories and bring data visualizations directly into the ways that you're presenting these results. And so this is asking questions of when was the hottest day where I am, and you sort of have a sense of place connection to the story as well. And so this is sort of a really interesting place to play that allows the connection between software and data, allows for that rich exploration between software and story, allows for a different type of connection, both in terms of people as well as to ideas. And that what we know well from the scientific literature is that story and data provide understanding and comprehension. And at the middle of this is learning and discovery. And as researchers in this space, we are playing the game and sort of the dance between research and publishing. And this is where those ideas of these sort of continuous tools that stitch together the workflows and support that process of research and publishing is so important. And where we are today is quite far away from that. Sort of, if we think about sort of an intricate choreographed dance between being able to publish, that is not how it feels today. Especially when sort of submitting to journals, it costs, in terms of time, $230 million for scientists to reformat their work for new publications. And the peer review process takes 1 to 8 months to get through with a 77% rejection rate. And the work that we have is static, and it's still often paywalled. And much of this comes down to that sort of idea that print is so ingrained at the center of our processes. And that creates these manual, closed, and inaccessible workflows between research and publishing. And some of the tools that we're building with MyST Markdown and Curvenote are aimed at these things, of trying to move this into a more automated process, to make it more open, and to make it more accessible to everyday researchers. So when we connect how we work to how we share, it is really powerful. Like thinking about platforms like GitHub or Wikipedia, those are mediums that allow working and sharing in the exact same space. And I want to draw a very imperfect analogy to a different discipline of knowledge work, of software development. And this same sort of idea of this process that you go through to create software, as you gather requirements and you design something and you start to develop it, and then you release it. And at that point, you get feedback. And that is actually when you get your actual requirements. And this is called waterfall development. And this is something that has very much sort of gone out of favor in software development because of that idea that you are working on the wrong thing for potentially many, many months. And so these ideas of continuous development are trying to go through this process as fast as possible. So going from planning to designing to building and coding, and then these automated systems to get your work out and release it. So testing and integration and releases, to deploying it such that you can get feedback and monitor that, and again, go back through the system all the way through. And so what these sort of continuous systems allow is for feedback to get back into such that you actually develop the right idea or the right product in their case. And so comparing these methodologies for how to develop and release software has been very well studied. There's a lot of, there's lots of software companies out there. And so some of these studies are comparing the speed of iteration and the robustness of software delivery. And in terms of the speed of iteration, that is 46 times faster, comparing the sort of waterfall techniques to the continuous development techniques. And that checks out with, if you are thinking about a software team that's only releasing monthly or maybe biannually, compared to software teams that release software multiple times a day. And so that is going through this as fast as possible. And then comparing to robustness, there is much more focus on automation to support that being able to go through this process as fast as possible. And the change failure rate in these systems goes down by 7x. And so this is sort of much like riding a bicycle. So some level of speed actually improves your ability to stay upright. And that is only true if the system is working and there are automated processes in place that are actually accessible. And so these, of course, are not one-to-one analogies, but I do think there are things that we can learn from continuous software development and ideas of sort of continuous science and releasing things as you go. So going from planning and collecting data and analyzing and authoring and tools for automation to get that out into review such that you can publish it and refine it and start again. And the pieces that are missing are those automation pieces to be able to richly link the way that we research and the way that we publish. And so things like automation for checking metadata, publication quality, and connecting all of these things together sort of supports that seamless and choreographed dance between research and publishing and feedback and the next idea. And so I think these ideas of software and story and data and bringing them together are very powerful. And so what if our scientific papers allowed us to explore data directly in them? What if you could push a button and actually bring up computational resources and attach them to your papers and run simulations that other people have prepared for you? And ideas of at sort of the center of learning and discovery, of thinking about this as an open science commons, of being able to hover over a footnote, dive deeper into research, pull out someone else's figure, and go all the way down into the data and the software directly. And integrating computational models and ideas directly into the text that we're writing so that we can change ideas and see the text even update. And continuous processes for connecting research and publishing requires some of these, especially computational tools. And this is saying MyST Start is the MyST Markdown ecosystem. And you bring up directly that sort of post or that publication quality article that you can see directly and interact with. And so putting those tools directly in the hands of scientists. And then also those tools for checking and automation and testing. So being able to run checking and see those tools that publishers run often in terms of metadata checks and DOI checks and ORCID checks and credit reference checks and those sorts of things. And actually bring those directly and put those in the hands of scientists directly. And again, that allows them, the researchers directly, to actually be a little bit more in control of how they're presenting their work. And of course, we can get PDF documents out as well. And so we don't have to give up the sort of scholarly ecosystem and tools that we have today. And so I want to go through a couple case studies. The first one is a microscopy journal that we're working with. And so this is the team 1 at Lawrence Berkeley National Lab in California. And it's a 2-story high microscope that records things at 120,000 frames per second and outputs data at 480 gigabytes per second. And so that is the same as the upload rate to YouTube globally. And that is from one camera, and that is going into then a journal, which takes a static picture of that. And that is frustrating, not least of which because you have to be able to zoom into these images. So this is actually a 1.5 terabyte image of a zebrafish. And in the journal publication, you need to like talk about it. So you have these zoom ins, and all you have is a PDF document to actually hold on to these ideas. And so we've been working quite a lot with Colin, who's the editor-in-chief at a new journal by the Microscopy Society of America, who reached out with the goal of creating, with some of these tools of the MyST Markdown and Curvenote ecosystems, journals that are possible to showcase data and software in a new way. And so this is the journal launched on Monday. So very, very sort of similar landing experience, all of the same sort of metadata and ideas that we need for scholarly publishing today, but with ideas that you can, again, push a button, spin up computational resources, and then actually interrogate the results and understand their data. And we're encouraging them and helping them publish much more of their work. And so they can go from that published figure directly into the code that generates it. And we're supporting the entire environment behind it as well. And that has some quite interesting outcomes, especially in working up to this launch, that sort of connection back into the software and the data. They were shipping software changes to support their new journal artifact. And so we're seeing sort of the push and pull between research and publishing in sort of a very healthy way, and pulling that knowledge back and sort of connecting them more richly. And very similar to the JOS workflow, you can have GitHub integration. And so there's graphical user interface based on sort of all of the checks that things are going through so that people can explore them, as well as the full rendered art all the way through. And so as people are actually developing their preprints, as they evolve into journal articles, we're sort of supporting them all the way through that process. And then this picture of a zebrafish actually is real. And so you can just keep on zooming in. And so this 1.5 terabyte image is just embedded directly in there, in the same way that you actually don't download Google Maps entirely, but you can still zoom anywhere in there. We can do really interesting things using the tools that scientists have already built. This piece was done actually in a hackathon at SciPy to integrate this in, and is using existing standards. But because of sort of the flexibility and inclusion in the Jupyter ecosystem, we can do quite interesting and new types of visualizations. Okay, one more story. So Lindsay Hagee is a professor at UBC. She's studying, well, she's a professor. She's researching, studying carbon capture and storage and geophysical methods for mineral exploration, and is trying to design her new lab to look at some of those things that I felt in my PhD when I was going through it, of sort of knowledge just walking out the door in data, and that sort of lack of organization, so that that we don't sort of lose all of that. And what you're left with is, again, that sort of static links to stories without sort of that underlying reproducibility. And she wasn't satisfied with that status quo, and having sort of decades of work and just a CV at the end of it, with a limited ability to tell her own story sort of throughout this research. And so she's been, and her group has been working on a lot of different things in terms of educational apps and computational textbooks and deploying those in courses and writing papers as well. And again, many of these published artifacts do not fit the mold of a journal article, and they're difficult to publish on their own. And these sort of interactive widgets that explain a concept or textbooks or blogs or notebooks or ideas or presentations, they just don't really fit in science today, but they have such utility and value. And so one of the things that we've been working with Lindsay's lab on is bringing some of these professional tools into that lab group context and providing them ways to show off their publications and show off their own research stories and through lines and better ways to communicate that work and pull in different ideas of textbooks all the way through such that you can actually see all of the sort of compendium of work that's going on at that lab, and a better way to communicate that and have sort of control and creativity on how we communicate. And that includes things like meeting notes and presentations and starting up little mini conferences and having that be archived as well. And that has changed the way, because of this sort of like new interface that she can curate her work and show her work through, that has changed the incentives around archiving and actually getting collaborators to work towards these things because there's an outlet to actually publish that in and share that in. And so this sort of idea of continuous science and actually connecting the research and the publishing, the working and the sharing is opening new collaboration mechanisms. And many of the people that she's shared these openly have come into her lab at a later date. And so actually both of the people on the Zoom call that are using some of these tools who were previously not collaborators have actually come in collaborators. And so practicing this sort of continuous open science opens the door for collaboration and growing the community around these ideas. And so going back to where we are today, I think innovation is not just about a fancy journal article with interactive widgets and going sort of beyond the PDF. It's about connecting software and data and story with a focus on learning and aligning work all the way through societal impact to collective understanding to personal ambition to change a field. And so from gravity to gravitational waves, each of these discoveries has been monumental, but in the arc of history, it's not the current theory, scientific theory that we celebrate, it's the scientific process that we use to show how that theory can be improved. And so imagine a future where Hooke and Newton were not rivals, but close collaborators, publishing their ideas faster, more openly, and more iteratively. So what discoveries would society have unlocked sooner? So thank you so much.